heart, the at the heart, the issue is that what we know that real research looks messy, but what ends up getting published looks a lot tidier and neater and more impressive than what it should look like if it was reported accurately. There's some kind of meta research quantifying the degree of how positive the literature is. This is a graph, sorry, it's very blurry, but I'll summarize it, from journalist Ed Yong's piece on summarizing the meta research about what proportion of published findings are positive findings, so significant or support the research hypothesis. And psychology is at the bottom there with over 90% of published findings are positive findings. But we're in good company with materials science, pharmacology, clinical medicine, biology, and biochemistry, all hovering around 90%, economics. And environment and ecology is actually doing much better, so it's around 75% near the top. Of course, it's not clear what the ideal rate should be, but 90+% is not good, right? In order for that to be accurate, it would have to be the case that our research hypothesis is true close to 100% of the time, and we have close to 100% statistical power in our studies, and neither of those are plausible. And so there's mounting evidence that these positive findings in the literature can't all be true, and that a concerning proportion of them are probably false positives. So some of this actually comes from research on registered reports. So you've probably, oh, sorry, actually, before I said, so this is another estimate of the proportion of negative findings in the literature. So the blue proportion is the proportion of published findings that are null results or don't support the research hypothesis. And this was done across the bio and social sciences. And so it ranges from 5 to 20%. But again, psychology is closer to 5% of published findings or negative findings. So what's going on here? I'm going to go through this part really fast because I think that this community in particular is aware of the problems, the questionable research practices that lead to this. But just so we're all on the same page, I'll talk about a few of them in the language that I'm using around them. So one is what's known as harking or hypothesizing after the results are known, which is where you might have had one particular hypothesis, or maybe you didn't have a particular hypothesis, but a kind of general idea of what you were looking for. You didn't find that, but you found something else interesting, and then you write up your paper as if that's what you had predicted the whole time, or it makes sense theoretically. You kind of imply or explicitly say that that was what you were looking for. So you end up looking like a really good shot. So that's one of the ways that we kind of turn what should be a messier result into a prettier one. And in psychology, I used to teach to graduate research methods students that that's what you should do. We had a paper that was a classic paper on how to write a psychology empirical article. And we would say, like, don't write the paper you thought you would write when you design the study, write the paper that makes the most sense after you've seen the results. And there's some version of that, like a little bit of that is probably okay. Like there's some things that might be okay to leave out, or a little bit of simplification that's okay. But to completely misstate what the aims were, what the expectations were, and to present serendipitous or unexpected results as if they were expected, especially when you're using statistics that assume that everything was planned, like p-values, is wrong, we now understand, and increases the rate of false positives in the literature. Also, p-hacking, I won't go into this very much, but I think one thing that's important about p-hacking is that you can do it without realizing you're doing it. And so I really like this quote by the authors who coined the term p-hacking in psychology. So Joe Simmons, who's the first author on the false positive psychology paper, wrote, so a journalist was interviewing him and said he and his colleagues have been very explicit that p-hacking isn't necessarily a nefarious endeavor, but rather a human one, and one that they themselves had been guilty of. At its core, p-hacking is really about confirmation bias, the human tendency to seek and preferentially find evidence that confirms what we'd like to believe while turning a blind eye to things that might contradict our preferred truths. The hacking part makes it sound like some sort of immoral behavior, and that's not helpful, Simmons says. People in power don't understand the inevitability of p-hacking and the absence of safeguards against it. They think p-hacking is something that evil people do, and since we're not evil, we don't have to worry about it. But Simmons says that p-hacking is a human default. It's something that every single person will do, that I continue to do when I don't pre-register my studies. Without safeguards in place, he notes it's almost impossible to avoid. And that's been my experience as a researcher too. And now I would say, even when we do pre-register, we still p-hack. It's like, it's really, really hard to avoid p-hacking. And we can talk more about that if people are interested. File drawing, so deciding not to submit a manuscript at all if the result doesn't confirm the research hypothesis, and then publication bias, the flip side of that, which is journals not allowing authors to present null results honestly. So really there's kind of a confluence of vested interests and motivated reasoning that lead published research to look a lot prettier than the truth would be. So researchers are engaging in motivated reasoning because they want to believe their research hypothesis, also their funding sometimes depends on it, and so on. Journals want the prettiest results either. Again, that might be a conscious thing. Some journals are pretty explicit about looking for that. Other journals might do that more implicitly or not realizing that they're penalizing more honest reporting. So bad research practices are rewarded, and this leads to a vicious cycle. So we now understand some of the causes of false positives making their way into the literature at a much higher rate than we thought. And we also have the evidence that that's the case. So this was kind of the 1-2 punch that led to psychology's replicability crisis. On one hand was simulations and kind of conceptual arguments showing that if we engage in these practices like p-hacking, it will increase the false positive rate just mathematically. And then on the other hand, empirical data from meta research showing that indeed there are probably a lot of false positives in the literature. So part of that evidence comes from replication studies. So this is a very oversimplification of a number of multi-site, multi-study replication projects in the social sciences, doing kind of a vote counting approach to whether the replication succeeded or not, which of course is not ideal. So take this with a huge grain of salt. But if we combine a number of large-scale replication projects across the social sciences, mostly in psychology, mostly from original research published in top journals, the success rate is something like 46%. Again, put a wide confidence interval around that. But even if we do that, that's still extremely low, considering these are mostly studies that had a pretty high impact and were published in pretty selective journals. Interestingly, it's not just replicability that's a problem, but meta research looking at reproducibility. So here I'm using replicability to mean if we collect new data, can we get a similar result? Reproducibility I'm using to mean if we use the author's own data, can we reproduce their results in their paper? And there's some evidence from Tom Hardwick and his work looking, for example, at a set of articles that were published in a journal with the data in code. And so this was relatively rare in psychology at the time, still relatively rare. So these were authors who were engaging in more open practices than was the norm for the field. And despite that, Tom's work showed that about a third of those articles were reproducible to Tom and his team without any assistance from the authors. About a third were reproducible only after contacting the authors and getting their clarification on some things, and about a third were not fully reproducible despite author assistance. This is a fairly high bar where every single result in the paper had to be reproducible to meet this. But as I'll show you later if I have time, this is not unusual. So even papers with open data and code are not always easy to reproduce. So this kind of feeds into the concern about a credibility crisis, that the findings may be false positives, and they may not even be positives in the first place. Some of them might not be there even in the author's own data, or at least be hard to verify. Now, the other source of evidence I find really interesting, and for me was kind of the third punch after the 1-2 punch, was an estimate of replicability from a different source, which is registered reports. So I mentioned before this paper that looked at the proportion of positive results or negative results in the traditional literature. In psychology, it's about 5%. And these authors and some others compared the traditional literature to the registered reports literature. I bet you all know what registered reports are, so I won't go through this, but the idea is that it closes the door to a lot of sources of bias. So what happens when authors have to stick to a plan and journals have to accept the paper regardless of the results? So several different meta-research studies have shown that for these early adopters of registered reports, the success rate of the studies, the number of positive findings is about 45%. So most of the early registered report results, the key finding was a negative or null result. And it's similar if we restricted just to studies that were replications of original research. And the original research there had, 95% success rate roughly, whereas the replications had 34% success rate. What's interesting to me is that these estimates are really similar to what we're seeing across replication studies. So we're having converging evidence pointing to the fact that perhaps a lot of the original literature, at least in psychology, may not be replicable. There might be a lot of false positives. There are other possible explanations for this pattern of findings, and I think meta researchers are looking into that. But to me, there's enough reason for concern in psychology. So what this experience of seeing psychology go through this crisis did for me as a researcher, as someone who taught research methods and who taught poor research methods, and also as a journal editor. So I became involved in journal editing around the time of the replication crisis, and now I'm very involved in journal editing, is asking like, where are the safeguards? Why did this happen? And why did it get so bad? And what can we do differently? And also, what could other fields learn about our mistakes? So if a scientific discipline was worried that it was going down a path of low credibility, what could they do to make sure that this doesn't happen again? And what's interesting to me in all this also is kind of thinking about, well, it shows how fallible scientists and science is. But we know that the public has really high trust in science. Maybe this has changed a little bit in recent years. These data are now from a few years ago, but trust in science, both this is data from the US, but Pew has also done research around the world, and in many countries, at least countries similar to the US and Western Europe, trust in science and scientists is quite high. So this is the green numbers here, show the proportion of respondents in a representative sample in the US that say that they have a fair amount or a great deal of confidence in scientists, and it's as high or higher than almost any other group of leaders. But what's interesting to me is in the same Pew surveys, they also ask respondents about what they believe about individual scientists. And here we see that respondents are not naive. They understand that scientists are not superhuman or noble or, virtuous. So when asked, do scientists admit and take responsibility for mistakes? The respondents said mostly no. So here the green dots are the response about research scientists across different sciences. You see that respondents understand that scientists are not, saints. They're human, and humans notoriously do not admit and take responsibility for mistakes. So the trust in science and in scientists doesn't come from trust in individual scientists, but from something else. And this was captured, I think this is consistent with what a lot of philosophers of science are thinking these days about where does objectivity and trustworthiness come from in science, not from individuals being objective and trustworthy, but from some social process. And actually, this was captured in a quote by a methodologist in psychology in the 80s who was writing about this kind of thing, and he wrote, "The dependability of scientific reports comes from a social process rather than from dependence upon the honesty and competence of any single experimenter. Organized distrust produces trustworthy reports." So here he's referring, organized distrust refers to a norm in science by the sociologist of science, Robert Merton, which is about, this norm that it's okay to criticize each other, and that's expected, and that's what we do, and that's how errors get detected and fixed. So this organized distrust or organized skepticism is actually really, really important because we're fallible, because we make mistakes and we don't like to admit it or see it. We have to have this organized skepticism, organized distrust that comes in and checks things, and that's what leads to self-correction in science. So when we pause and think about this idea that science is self-correcting, which I used to kind of take for granted and teach to undergraduates, but because of the replication crisis, I had to stop and think, what do we actually mean by that? I think that this idea of organized skepticism is really fundamental to that. But it hasn't really been fleshed out that much, or I couldn't find much literature on what does this organized skepticism look like? Where can we find it? Where can we point to it? And I really enjoyed Naomi Oreskes' work, who's a historian of science. She has a TED Talk called Why Trust Science, and then she published a book with the same name. And I was looking through the book looking for okay, she talks about the self-correcting mechanisms in science and this organized skepticism idea. And I wanted her to get into really concrete details about what that looks like. And I was kind of disappointed. So she wrote things like, how do we know that science is self-correcting? Well, the same way we know other things, we observe it. And when we observe scientists, we find that they have developed a variety of practices for vetting knowledge, for identifying problems and attempting to correct them. And to be fair to her, she does talk a little bit about peer review as one example of this. I can get into why I don't think peer review is nearly enough to catch, it's not designed to catch all errors, and we need a lot more than that. But I was frustrated with not finding the answers I was looking for, which is my own, I had my own agenda. And also I felt like this was a little bit too idealistic. And my experience is more similar to that of James Heathers, who you might have heard of. He's an error detector in science with a background in psychology and physiology. And so in an old tweet, he wrote, in reality, the mechanisms to correct bad science are slow, unreliably enforced, capricious, run with only the barest nod towards formal policy, confer almost no reward, and sometimes punitive elements for a complainant who might use them. And that's been my experience, actually, not so much as an error detector, I'm not that good at it, but as a journal editor and an author who's made mistakes and had other people correct them. When I see what the process looks like to actually try to issue a correction, I just had a meeting this morning about, can we change the norm around when somebody points out an error in a published paper? Most publishers, in psychology at least, have a rule that the correction notice cannot acknowledge the person who identified the error. So I'm trying to get that changed, and it's crazy that that's a hard thing to get changed, that that's even something we have to ask, and that the initial response is, no, that's not done. Why? That's the least amount of recognition we could give to people who do this thankless work. So some people might say, well, self-correction in science is there, and in fact, psychology's replication crisis and similar crises in other fields are evidence of self-correction. That's what normal self-correction looks like. And indeed, that argument has been made by some of the most prominent voices in my field in psychology. So, for example, in an annual review of psychology chapter, which is one of the more impactful publications that comes out each year, some very, very high-profile psychologists wrote about the replication crisis kind of in the middle at the peak crisis time. And they wrote, all of this that's happening is normal science, not crisis. A replication failure is not a scientific problem. It's an opportunity to find limiting conditions and contextual effects. Of course, studies don't always replicate. Now, there's a version of this that I completely agree with. I don't think the replicability rate should be 100%. I think it's completely normal that some things will fail to replicate, sometimes because of boundary conditions and so on, and sometimes because of false positives. We should accept that false positives are going to make it into the literature. And there was a similar sentiment echoed in a report by the National Academy of Sciences. So I was on the National Academy of Sciences committee in the US, tasked with writing a report on replicability and reproducibility in science. And one of the early chapters was about how, we want to distinguish between normal error in science and a crisis. And one of the sentences that ended up in the report was, the advent of new scientific knowledge that displaces or reframes previous knowledge should not be interpreted as weakness in science. And again, there's a version of this I completely agree with, and it's important that the public understands that we should be making errors in science. If we're making no errors, we're doing it badly. The problem I have with both of these quotes is that they don't grapple with the issue of, okay, but we shouldn't get a blank check to make any and all errors over and over again, right? There's a certain pattern of errors that is a sign of something going wrong in a field, and that a field needs to kind of reform itself. And I don't know where that line is, but I think that psychology crossed that line. That the state that we were in when the replication crisis forced us to do some introspection, I think what we found is worse than what should be accepted as normal science, normal amounts of error. And in fact, some of that comes from the reaction to the initial replication studies and so on in psychology. So if it was normal science, we would have welcomed those findings, those corrections, etc. But actually, the very same people that are saying all of this is normal science, those leaders in the field in the early days of the replication crisis, their reaction to replication studies or corrections or criticisms were calling the people doing that work things like replication bullies, human scum, methodological terrorists, second stringers, destructive iconoclasts, and my favorite, accuracy fetishist, as if that's a bad thing. And I think it's important to recognize that if this was normal science, it would not have elicited this reaction from the very top people in the field. And so to me, when people in psychology say what happened in our field is evidence of self-correction and we should pat ourselves on the back and it's completely fine, reminds me of this cartoon that, things were actually much, much worse than we should have been okay with. And the reaction to the correction was not welcoming it with open arms and saying, oh, thank you for helping make our science self-correcting. And we often see this panel of the cartoon, but we don't see what happens later. And I think it's a cautionary tale that we don't want to be in this world. So thinking about what could we do if we want to make our science more self-correcting, if we're concerned, if we think that what happened in psychology, we don't want it to happen again, other fields don't want it to happen to them, then how do we get to a more self-correcting system? So how do we have organized distrust or organized skepticism so that we can have self-correction? And in thinking about this, to me, there's two fundamental pillars of a commitment to self-correction. First, you have to have transparency, because if you don't show your work, then other people can't find the errors. So if a field is really committed to self-correction, it should require, or almost require to the extent ethically possible, that research be reported transparently. And then we need to actually go in and check things. So have organized skepticism have a role and a reward and incentive for people to use that transparency to check things. So to use a metaphor, transparency would be like saying you have to let people look under the hood, right? If you're selling a car, you can't say, no, 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 don't look under the hood. And if you're selling a research finding, you can't say, no, 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 don't look at my data, or don't look at the protocol, don't look at the materials, etc. You shouldn't be able to say, just take my word for it, if it would be relatively easy and safe to share the stuff that lets people verify it. But allowing people to verify it isn't enough. We actually need to make sure we have mechanics, to take this metaphor further, who go in and stress test the results, who identify errors and bring them to light, and then people take them seriously and actually fix them. And so what I'm going to argue today is that we're making good progress on transparency in many fields, I think, and in psychology in particular. I'll show some data. This thumbs up is way too optimistic. But just to show the progress that we are making in psychology, but also how much room we have left, I'm going to again refer to results from Tom Hardwick, who I think has done some of the best and most important work tracking changes, reforms in psychology. So this was from a paper published recently. Sorry, it's no longer in press. It's now published. Comparing the rates of sharing of different things. So this, in this case, data sharing in psychology articles, kind of in the before the replication crisis had really had a chance to change behavior. So 2014 to 2017 would be papers that were published just a couple of years into the replication crisis. And then estimates from 2022, so after the replication crisis had had time to change practices. Of course, I don't know that that's the causal mechanism here. And we had two estimates from 2022, one of a representative sample of journals and one from a sample of high impact journals, basically. And so what you see is that data sharing was basically non-existent 10 years ago. And then 3 years ago, it was still very rare. So still only 15% of articles had open data. And this wasn't checking that the data was usable or anything like that, just that there was something that looked like data that was publicly available or easy to access. And so it's an order of magnitude increase. So that's a huge increase, but also lots of room to improve if we consider that probably the ideal rate of data sharing in psychology is not 100% because there are papers where sharing the data would be scientifically unethical or irresponsible, but it should be much higher than this. And we find similar patterns for sharing of analysis scripts or materials, pre-registration also, right? So a huge increase in absolute terms, but compared to what arguably an ideal rate should be, much higher, still a long way to go. But one of the other kind of encouraging signs about progress on transparency is that in addition to seeing change in behavior, we're also seeing changes in the structural elements of the field and of the scientific ecosystem. So we have more organized communities like SORTEE, and this is more heavily biased towards psychology communities, but I think across the sciences, there's more and more organizations for learning how to do open science, learning how to be more transparent, rewards for doing open science, initiatives, things like that. And they have gone from being bottom-up grassroots initiatives to now being established institutions. So SORTEE, I think, is a good example of that. Our equivalent in psychology, SIPS, the Society for the Improvement of Psychological Science, also has become, pretty mainstream in psychology. Well, maybe that's going too far, but it's no longer as marginal and bottom-up and grassroots of an organization as it used to be. So to use Brian Nozick's pyramid of cultural change, which he uses when talking about changing open science practices, for increasing transparency, I would say we've done a lot of progress on making it possible and making it easy for researchers who want to be transparent. We're now at the stage of making it normative and rewarding. So we saw it's not quite normative yet in psychology to share data and so on. And I would argue that actually staying at this stage too long is bad because it creates really perverse incentives if people can choose whether or not to be open and transparent. As a journal editor, it's really, really hard to compare the value of research that is transparently reported and has flaws. You see that there's some flexibility. You see that that things aren't as pretty and neat as the story might be presented as, versus a manuscript that presents a neat and tidy story and you can't look under the hood. You can't evaluate whether that's the full story. How do you compare those two papers as a journal editor? How do you make it fair? You either have to give the benefit of the doubt to the non-transparently rewarded paper, which isn't fair to the people being transparent, or you have to assume that the non-transparent paper has a bunch of flaws and problems, which upsets authors when you do that. So it's really hard, I think, to keep incentives aligned with good practices when good practices are optional and opting in might hurt you. So I think as a field, we need to try to move towards making it required as quickly as possible now that the tools are there and the resources are there for people who want to be open and transparent, making sure to keep an eye on inequities in those resources. So at the journal that I'm editor-in-chief of, where I asked Tom Hardwick and he happily agreed to be the senior editor for Statistics, Transparency, and Rigor, we published an editorial at the start of our term saying that from now on, transparency is going to be the default at our journal. So authors, by default, have to share data, code, materials, and we check the computation reproducibility of papers. Again, we make exceptions when that's in the best interest of science for ethical reasons and so on. So that's great. Like, I think transparency is getting traction. I don't think we should kind of rest on our laurels. We still have a lot of improvements to go on transparency, but I'm also worried about focusing on transparency to the exclusion of what transparency is for, which is detecting errors and correcting them. Andrew Gelman has a nice, like really, really short paper called Honesty and Transparency Are Not Enough, where he emphasizes this. He says, consider the consequences for a researcher who eagerly accepts the message of ethical and practical values of sharing and openness, but does not learn about the importance of data quality. They could then just be driving very carefully into a brick wall, conducting transparent experiment after transparent experiment, and continuing to produce and publish noise. So I think this is something we're seeing kind of the growing pains of in psychology, where people are starting to accept that transparency will be expected of them and that that's a good thing. But we still see a lot of resistance and a lot of concern about checking. So people are happy to share, but then if you point out that their pre-registration says something different than their paper, people are like, but you just told me I should pre-register. I wasn't, that wasn't part of the deal. So I think that as hard as it's been to make gains in transparency, it's going to be even harder to make gains in actually checking the transparently reported material and detecting errors for a number of reasons. One of them is, as Kurt Vonnegut said, that a flaw in the human character is that everybody wants to build and nobody wants to do maintenance. And I actually think that's not quite true, right? There are some people who really like doing maintenance and who are really good at and really enjoy error detection. So it's a double whammy problem. I think there's not that many people who go into science wanting to do this, but the ones who discover that they're good at it and like doing it, we also don't reward and don't provide roles for. So I think what's important to remember here is that in science, I think we often have this idea that science is self-correcting and that'll happen on its own, but we actually have to create roles for and incentives for the people doing the self-correcting. Or to quote James Heathers from an old tweet again, he said, science is self-correcting, sure, when we correct it, not because of magical progress. And I know this sounds really naive, but I think for many of us who were kind of in the front lines of psychology's replication crisis, this was like a major realization that actually we can't just assume that time will lead to self-correction in science. We have to make sure we have safeguards and checks in place. We have to make sure that not only are we asking people to lift the hood, but that we're training people and rewarding people and incentivizing people to do the error detection and correction. And we're starting to see some of that in psychology, but again, it's very grassroots, very bottom up. So I'm just going to go through very quickly a couple of examples, focusing specifically on the journal that I'm editor-in-chief of. There has been some meta research assessing how we're doing on some aspects of error, making sure our articles are accurate. So one early paper led by Tom Hardwick looked at reproducibility in articles receiving open data badges at the journal. So this looked at 25 articles that were published in 2014, 2015, and found that 36% were reproducible without author involvement and 60% after author involvement, but still, 40% were not, even with author involvement, even when the data were publicly available. And there have been more recent similar evaluations of the journal. So Sophia Cruel led a team looking at 14 psych science articles published in 2019. So now we're going 4 or 5 years forward in time. Only 7% were exactly reproducible and 29% were essentially reproducible. So again, I mean, the fact that there were articles with open data and code and stuff was in some ways better than the norm in the field, but even then we still have so much room to improve. There was also I think this was an undergraduate thesis looking at 80 analyses in 3 articles from this journal published in 2022-23. Again, found a lot of room for improvement in the reproducibility of the findings. This is using the author's own data to try to reproduce the results in their own paper. Another indicator of how journals are doing in making sure that errors are detected and corrected is looking at journals' policies and practices around commentaries that point out errors in published papers. So one of our honor students with Tom Hardwick, Annie Wamond, led this project, and she looked at the post-publication critique policy in prominent psychology journals and looked at whether their website, anywhere on their submission guidelines or article types, etc., said that they accept post-publication critique. They didn't have to use that phrase, but somehow if you found an error in a paper and wanted to write a commentary or letter to the editor about it, could you do that? And most either implicitly or explicitly did not have an avenue for that, even though I think it's in the COPE, Commission on Publication Ethics guidelines, that journals should have such a mechanism. And even when they did have such a mechanism, they often had pretty strict restrictions on either length, that was more common, or time to submission. You had like a short window after the target article was published to submit a commentary. If you found an error later than that, too bad. They didn't want to hear about it. So journals are not doing great in terms of incentivizing error detection and correction. And my experiences at journals and being frustrated with how hard it was to improve these processes led me to write an article in Wired about how peer-reviewed scientific journals don't really do their job. And part of my argument there is that it's people expect a lot of journals as kind of this idea, if we think about where the self-correcting mechanisms are in science, and many people point to peer review can't do all that work. That's way too hard a job to put on one point in time of one version of an article. There are going to be errors we don't catch. There are going to be errors that we couldn't have known about until, new methodological advances point out problems with earlier methods and so on. So error detection and correction shouldn't start and end with peer review. But even then, the amount that peer review could do, it often doesn't do. So we're basically asking the scientific community to do unorganized, volunteer, grassroots work, finding errors after the fact. And even when they do, we often don't reward them, don't thank people who do that, and often institute a punishment on the people who do that. A couple of years ago, that punishment became very, very concrete and high profile in the case of whistleblowers who found evidence of research misconduct in Francesca Gino's work. So you might have heard of her. She's a behavioral scientist. She was at Harvard University. And she was credibly accused of fabricating data. Harvard fired her or put her on leave without pay. And she sued Harvard and the whistleblowers and sued them for $25 million. And that had a very chilling effect on people who were pointing out errors, not just fraud, but also honest errors. It's very scary to go up against a, high profile person with a lot of resources. Luckily, her lawsuit against the whistleblowers was dismissed, and I think there's a really important lesson in that should help kind of provide some reassurance to whistleblowers who are considering critiquing problems in published research, which is that the judge in that case, when he dismissed the lawsuit against the whistleblowers, referred to another judge's ruling in a different case where it was a similar thing of researchers pointing out errors in the work of an engineer, and the engineer sued the critics for, I think, libel or defamation. And the judge said, look, you're a public figure when you publish your work, and you're basically, these laws about, libel and defamation don't apply to public claims about research made by a researcher. So he wrote, not so that this obscure engineer in the previous case is not a public figure in the lay sense of the term, dealt with as an obscure engineer, but anyone who publishes becomes a public figure in the world bounded by the readership of the literature to which he or she has contributed. By publishing your views, you invite public criticism and rebuttal. You enter voluntarily into one of the submarkets of ideas and opinions and consent, therefore to the rough competition of the marketplace. So it was nice to see that a judge in the US at least upheld this really fundamental value, I think, of scientific self-correction. We can't have scientific self-correction if people are afraid that if they point out errors or problems in published papers, they're going to get sued for $25 million. And so one thing that this brought up for me is that really the organized skepticism that we kind of assume is there in science, and the reason why the public trusts science, this idea that we check each other even though we each aren't great at admitting our mistakes, it's actually very disorganized skepticism. We don't have really good institutions in place and protections and incentives in place for people to do this kind of organized skepticism. So I would say for finding errors and detecting and correcting them, we're barely at the make it possible stage. And we need to really move up this ladder and make sure that we're at least making it normative and rewarding that errors are detected and corrected. So one of the things we did at Psych Science, the journal I'm editor of, is we brought on this team of statistics, transparency, and rigor editors who help us kind of stress test manuscripts, especially as they get closer to acceptance. So we've added a couple of stages as papers move through peer review, where we have experts in methodology, statistics, ethics, things like that, kind of weigh in on things. And then we have this computational reproducibility check at the end before a paper is formally accepted. And you might recognize some of the names here are some of the same people who had published meta research about the journal, pointing out some of the ways in which we're falling short of our ideals. And so I think that's a really good thing I would recommend other journals do, is bring in your critics and say, hey, you pointed out some really important things. Would you want to come on and join the team and help us not make those errors going forward? There's also outside institutions that have cropped up that are focusing on error detection and correction. For example, the Institute for Replication, which started as a project looking at economics journals. So initially they were focusing on economics and political science journals, and they would do systematic reproducibility checks of papers in those journals and publish commentaries and meta papers summarizing at the journal level how the journals are doing in terms of computational reproducibility. And then they announced that they're going to start doing that for our journals like Science and Nature Human Behavior. So they're spreading to more social sciences, which is great. So we need more of this kind of organized skepticism, not just individual people who are taking the risk of getting sued. And even if they don't get sued, they often experience other negative consequences for pointing out errors. We need to kind of organize that. The people who are good at that, reward them, value them. So we need more skepticism, and we need it to be more organized. Um, in the interest of time, I think I'll skip. I'll just say there's a great paper by Felipe Romero if you want to read more about who should do this kind of verification work. He writes about replication, but I think it's true of verification work in general, and that many institutions and groups have a role to play in encouraging this work. We shouldn't leave it up to just individuals who feel like it and who have the right personality and skills and courage to do it. And another important point is that it's really important that this be a diverse group of people. And this is Naomi Oreskes, the historian of science, writing about this idea of social epistemology from Helen Longino, that the way that science reaches objectivity is through having a diverse community of people who can kind of cancel out each other's biases and out each other's background assumptions and so on. So it's really important that not just the research community, but also the kind of verification community have come from different backgrounds, have different preconceptions, biases, et cetera, and strengths, so that it's not just the same people catching the same things. So I will stop there and take any questions or discussions that you all have. Okay, I see in the chat there's a question. How can we better reward the organized skepticism? How to get more funding for folks to do this kind of work? I think that's a really good question. I'm